do that though, let's talk about the expanded octet. So like in that second row, those are the only elements that follow the octet. Why, if we go beyond that, can we take on more than 8 valence electrons? You might be wondering. So this next section is titled the, that's crummy. Can you guys see that okay? Yeah. The expanded octet. Okay, so we're going to ask ourselves the question, why does the octet rule fail? Ah, that's better. So how can something take on more than 8 valence electrons? And to understand this, we have to jump back to quantum numbers. So the thing we want to do is we want to consider the available values of L, the angular momentum quantum number, for an element in the third row. Okay, so to figure out the value of L, go back to those rules for quantum numbers. What do we have to know to determine L? What's the very first quantum number we need? So what was the rule to figure out L? Or what are the possible values of L that you could have?
N minus 1.
Yep, n minus 1 to what?
0.
Yeah, could have any of those values. So what do we have to know the possible values of L? Yeah, we got to know n. So if we're talking about an element in the third row, what is the highest possible value of n we could have in that third row?
2.
Yeah, 3. Okay, so n is equal to 3. What are the possible values we could have of L? 0, 1, and 2. And what are these things describing? Again, what if we have an L is equal to 0, what type of orbital are we talking about? Yep. S orbital. What about L is equal to 1? Yep. What about L is equal to 2? D. Okay, look at any of the third row elements. Somebody pick out one for me. What's your favorite third row element? Chlorine. Okay, I like chlorine too. It's really reactive. It does a lot of cool stuff. You look at chlorine. Does chlorine have any d electrons? No, it doesn't have any of them, right? You look on the electron configuration, or you look at the electron configuration for any of the ones in the third row, there are no d electrons. But what do we know about those elements? Do they have d orbitals? Well, based upon the quantum numbers, do they have d orbitals? Yeah, they do, but they're empty. So these guys do have d orbitals. They're empty though. They don't have enough electrons. They aren't occupied. But these second row element, or excuse me, these third row elements do have d orbitals. So L is equal to 2. These elements have d orbitals. The thing is there's just not enough electrons to occupy them. But they do not have enough electrons. To occupy them. However, these empty d orbitals, they can be utilized in bonding. So you can use these empty d orbitals to accommodate more electrons. So these d orbitals can be used in bonding. So they can accommodate more than 8 valence electrons. Elements can accommodate more than 8 electrons. And that's why the octet rule fails for these systems.